pray. Almighty loving Father, King of Kings, we want to thank you for today. And thank you for the gift of life, the gift of protection, the gift of our parents, friends, and teachers. As we are going to attend this lesson, we pray that may you send your spirit to come and guide us, come and give us retentive memory, that we can grasp everything that she is going to tell us. And above all, Father, may will be done. Jesus Christ, our Lord, of praise. Amen.
Amen. Thank you so much. You are going to allow me to mute everyone. But in case you have anything you want to communicate, always feel free to raise up your hand to ask. So I'm going to mute such that we don't have any background noise coming in from the different people. So in case there's anything you want to share, you will always be allowed. So I'm going to go on and share my screen. Yes. Yes, I can just have one person confirm the co-hosts. Martha K, you can confirm whether the screen is on.
Yes, teacher. It's on.
Okay, good. So today we are going to start a new topic and we are looking at physics. And the topic we are starting on is the senior 3 topic on linear motion and nonlinear motion. So this is a new topic. I'm very sure none of you has covered it yet. And that is the first topic when it comes to the physics syllabus. We understand that when you go back, many of your teachers will be pushing to complete the senior 2 work for those who have not yet completed. But we thought it wise that for us, let us push ahead such that we can be able to cover ahead of any other person. So that is the topic that we are going to be looking at. I'm going to ask you to write down the topic. Write down that topic. Okay, I'm seeing a hand up. Tanya Queen.
Sir, the timetable says today we are having biology. Am I in the wrong class? Or...
I think you are in a long class. Which class are you in? This is senior 3. I think Tanya Queen.
Yes.
Yes, I think hope you are not in the wrong class. This is senior 3.
Yes.
Okay. So, and our theme, the theme for this topic is mechanics and properties of matter. So that is the theme. You can also write it down. Hope now we have finished. We can go to the first thing. Now, when they talk about linear and nonlinear motion, do we have someone who wants to give us a hint? But I want you to look at these pictures, look at the pictures that have displayed on the screen, and just, you're going to, for me, just look at those pictures and identify which one do you think shows a linear motion and which one do you think shows a non-linear motion. So look at the screen, raise up the hand and tell us that this one, I think it is a linear motion. This one, I think it is a non-linear motion. So feel free, raise up your hand and share with us that this one is a linear motion. Okay, I will start with Tanisha.
So my thing G is a linear motion because people are marching in a line.
Okay, very good, Tanisha. That is good. So Tanisha is not saying that G is a linear motion. Good. Okay, thank you. Can we have another person? Another person? Raise up the hand. We can as well use the chat. Those who are not comfortable with raising up the hand, we can use the chat. Okay, Nakanyike.
I think A is linear motion because it shows that the apple is falling in a straight line from the tree.
Okay, perfect. Thank you. You are very right. Very okay. Desley.
B is a linear motion position.
I beg your pardon, which one?
I think B is a linear motion is developing.
Okay. So you're stating that, okay, your network is not so clear, but you said D? Okay, okay. Let me look in the chat. Jimmy is telling us that B is linear and F is non-linear. B is linear, C is linear, E is non-linear. Oh, okay, okay, okay. I think that is good. That is good so far. Okay, okay. The rest, feel free to try in the chat. D is linear, C is non-linear. Okay, good. Now looking at this, okay. Desley, do you have something to say? You can unmute.
I say that B is in motion with position. The force is
Okay, thank you. Now, what do we mean by linear and what do we mean by non-linear? When they talk about linear, linear means straight in English when we are using the English word. So it means something straight, something moving in a line. Or at times we can use the word rectilinear, like the way you are looking at light. So anything that moves in a straight line, we call it linear. So when we are talking about linear motion, we are looking at those things that are moving in a straight line. When we talk about non-linear motion, we are looking at those things that are not moving in a straight line. So anything that is not moving in a straight line, then it means it is non-linear. So anything that moves in a straight line, then we call that one to be a linear motion. Hope we are together on that. So if I've talked about, we have said linear, they move in a straight line. So when you look at part A, you are not saying that this is an apple and an apple is falling in a straight line. So we can say that A is a linear motion. When you look at G, you are noticing that these students are marching in a straight line. So we can say that it is linear motion. So I want us to use the chart. Type in any motion, any letter that demonstrates something that is not moving in a straight line. Type in the chat non-linear motion. Type that G, that these are the non-linear motion. Type in the chat, everyone. Type your answers in the chat. What we have as non-linear motion. For you, when you look at that, what you are noticing to be non-linear. Okay, perfect. Let me read. People saying F is non-linear. People are saying C. Okay, F, C. I don't know where. C, F, C, C, F, C. C. E. Some are saying D. Okay, this is perfect. Okay, 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 good. Yes. Now I want to ask, what about D? I want you to look at the minute hand. Which kind of motion is that? When you look at part D, type in the chat and let us, is it linear? Is it non-linear? When you look at part D, look at the minute hand. Look at this, at that arrow pointing in the clock. Is it demonstrating something moving in a straight line? It is demonstrating something moving in a non-straight line. So type in the chat and we see, okay, very good. Everyone here in the chat is saying it is non-linear. Very good. So that is the difference between what you call linear and non-linear. So when in this topic, we are going to look at things that are moving in a straight line. So anything moving in a straight line, we shall refer to that kind of motion as linear motion. So when you look at this topic, at these ones, so this is the linear motion because an apple will fall and will move in a straight line. This person pushing this object, the object is going to move in a straight line. So we shall also refer to this motion as straight. These students that are marching are moving in a straight line. So we shall refer to them as moving in a linear motion. When you look at this car is negotiating a corner. So meaning that it's going to move in a zigzag way. It's going to bend. So it's not going to move in a straight line. When a person kicks a ball at an angle, this person is projecting a ball and the ball is making a curve. So this is non-linear. This person that the dog is chasing also demonstrates a non-linear motion. Likewise, the clock. So those are the types of the different types. But each of these types here, when you advance in physics, we shall learn that we have in nonlinear, we have other types under nonlinear. We have what we call oscillatory motion. We have what we call projectile motion, like that. But those ones, we shall look at them at another time. Yes, hope that is very okay. We can now proceed to the next slide. Now, on the next slide, we shall have the learning. Okay, let me. Okay, it's the competence. So by the end of this topic, you can read it personal because I drafted it basing on a personal level. So just read it. We may not write it, but read it and then get to know what you are supposed to be knowing at the end of the topic. So get a minute. Let us first read it. Okay, hope everyone has finished. You can type in the chat, those who have finished reading. Okay, people are saying they're finished. So give them a few minutes to those who have not yet finished. You let us know whether you have finished. Okay, okay, good. Okay, good. People have finished. Okay, now I'm going to ask you, there is a task we are going to do. So you're going to read this story individually. After reading it through, you are going to answer the questions that are going to be followed. There's no need for you to write. I'm going to display bit by bit. Okay. The story is continuing. Can have one person who wishes to read for us. Any person who wants to read for us, you can raise up the hand. Okay, Patricia.
Kampala steady day out. In a lively city of Kampala, there were 4 friends, Stacy, Audrey, Bridget, and Frank. One day, Stacy had a fantastic idea to organize a race in the city park. The challenge was straightforward race from one end to the other as fast as they could. As the race kicked off, Stacy noted her friends moving in different ways. Audrey took a straight path, Bridget zigzagged, and Frank went in curves. Curious, Stacy also discovered the concept of speed, how fast things move. Audrey had a steady pace, like average speed, while Frank showed quick bursts of speed, like acceleration. During the race, the friends faced a challenge. The wind picked up, slowly them down. Stacy realized this was something making it harder for things to wind or rough surfaces could slow down, she thought. In the end, all 4 friends finished the race in different times. Stacy was thrilled because she learned about speed, distance, time, and cool science of motion. It turned out to be a short and speedy adventure that made Kampala known for the fastest and most run races ever.
Okay, thank you. Thank you. Now, I want someone to raise up the hand and tell us which statement shows a linear motion. Yes. From that story, I want someone to identify for us which part is showing a. Okay, yes, Valeria.
That part of Audrey took a straight path.
Perfect. Thank you. That is very correct. Okay, then which part is showing a non-linear?
Bridget zigzagged,
Okay.
and Frank went in. Oh.
Very good. Has everyone noticed that? Kindly let us know in the chat. Yes, has everyone noticed that those are the 2 statements that are depicting that this statement here, that Audrey took a straight path, is representing a linear motion. And this statement of Bridget and Frank moving in a zigzag and Frank moving in curves represents a non-linear. Okay, okay, that is very good. I'm seeing in the chat, people are responding. Good. Now, another question is coming in. Can we identify which word is suitable to fit in this space? In these 2 spaces, this is A and this is B. So can we have a boy? At least we have had some girls. Can we have a boy? Or you can even type in the chat, which word do you think is suitable for A and which word is suitable for B? Which word do you think is suitable for A and which word do you think is suitable for B? Let me check the chat. B is move. Okay, nice try, Prime. We are thinking. Yes, this statement should give you a hint. The wind picked up, slowing them down. Stacy realized that this was, which word do we use in physics to show resistance? Sorry. Oh, I think this accelerates. Okay, nice trial. Which thing, there is a word we use in physics. Very good, Faith. Yes, that is very correct. Very correct. I think people have been able to notice that word. That word is resistance. So that is a word that is missing here, resistance. And part B and B, someone mentioned it already. I think I said it by mistake. Part B, someone mentioned it already. Joyce, nice trial. Nice trial, someone mentioned it. We are now on part B. I'm still looking in the chat. Very good, very good. The word has started to come. Yes. Hope everyone remembers that when we talk about resistance, resistance means the opposition to the flow of something. Whenever something is slowed down, in physics, we shall say that is resistance. Whenever the motion is slowed down, the word we use is resistance. Now, our next, I want you to look at this story and identify those keywords. There are some new words here you are noticing. There are some new words, there are some keywords that are going to be vital for this topic of linear motion, of nonlinear motion. So I want you to raise up your hand and tell us that this word is a keyword. Okay, I will start with check. Check.
Okay, so one of the words I know is speed.
It is speed. Thank you. Let me risk to allow you to be able to unmute, but let us be disciplined. I'm just testing. In case you want, once we mention your name, you tell us. So yes, check has told us one of the words is speed. So I'm going to highlight that word of speed. Very good. This is one of the keywords. I have Jolene.
I think one of the words is acceleration.
Acceleration, good. Hannah.
I think one of the words is the motion.
It is?
Motion.
Motion. Did you mention motion?
Yes, it's in the last paragraph.
Last paragraph, okay, good. Another word. Yes, Desley.
I think resistance.
Oh, resistance, okay. Zanita.
Distance.
Distance, where is that word? Which paragraph?
The last paragraph.
The last paragraph, good. Any other word? Valeria? Valeria? Time. Okay, time, good. I have seen a gentleman, Paul. Okay, Paul is not talking. Sylvia. Paul, you can talk. Sylvia. Joyce. Okay, Sylvia, you can talk, no problem.
There is average speed.
There is average speed.
In the third paragraph.
Third paragraph, good. Any other word? Joyce, Fima? Okay. I think those are some of the words that we have been able to identify. Okay. So we are going to go on in our books and then write down those keywords. So write down any keyword that has been mentioned. Write it down, any keyword that you have had members mentioned. So write those keywords. Write them down. So also in the chat, I'm not seeing people. Okay. Okay. Write those keywords. Yes. Those who are finished, you can let us know in the chat in case you have finished before I give you mine. Okay. Okay. Have we finished? Okay. Looking at the chat, some people are saying they have finished. They have finished. Rama, have you finished? Rama, have you finished? Hope everyone has finished. Okay. Audrey, have you finished? Okay. Okay. I think everyone has finished. So you can add on a few words. Those are the ones I had. Those are the common ones. So in case there is any word that you do not have, you can add it there on your list. Check in case there is any word that has not been, any that you might have missed, kindly just add it there. Okay. Okay. I think we can now continue. Now, each of these keywords, we are going to look at it in details, what it means, how do we use it, and the rest of that. So we are going to study. So in this lesson, this is our key thing that everyone, by the end of the lesson, you must be able to know the relationship between speed, distance, and time, but also to know what is linear motion, what is speed, average speed, acceleration, and be able to investigate resistance to motion. So those are our objectives for this lesson. I'm going to start from here, looking at what we call motion. Now, when you look at the pictures displayed, you are not seeing that every item or every object is in motion. Now, if I may ask, what do you think motion is? Someone to try. What do you think motion is? In your own words. Okay. Okay, we can start with Desley. Okay, Desda, I think your network is not so clear. Your network is not so clear. Let me request a check.
Okay, sir. Motion is change of position of an object with respect to an observer.
Okay, change in the position of an object with respect to an observer. Very good. I have Van. Thank you. Van.
Motion is the action of movement or being moved.
Okay, thank you, Van. Okay, Valeria.
The ability of an object to move from one place to another.
Very okay, very good. Nakanike.
Motion is the change of position of an object with respect to its surrounding in a given time.
Okay, perfect, perfect. So every definition that members have mentioned, there is one keyword that has come out. One is the change in the position where an object is. Whenever you change an object, whenever you move from one point to another, we shall say that you have moved. So motion means the change in the position from where you have been to a new position. That's what we call motion. When you look at this car is moving from somewhere, maybe from point A, going towards point B. These people running are moving from one point, let me say C, to point D. So we can say that they are in motion. However, we shall always have them with respect to a given variable. And in most cases, that variable is the time. So you look at the time those people are taking to move from one place to another. That's what you call motion. So you can write. In case you have a question, please feel free always to ask. When you finish, we can communicate. Okay, I'm saying some good definitions in the chat. People were mentioning some. That was really very good. Joyce, Emily, Melody, PC, Teresa, Cherop, Rama. Okay, that was very good. Yes, these definitions I'm seeing in the chat, they're also very correct. Okay, okay, good. So when you finish, you let me know, and then we can proceed. Okay. So far 4 people have finished, so we shall add them a minute. I feel. Yes, Nakanyike, you have a question?
Yes.
Okay, ask.
Why is it that motion is the change of position of an object with respect to its surroundings? I thought it's just the change of position of an object in a given time.
Okay. Let me ask class. Anyone who can answer her? Anyone who can answer her? So, okay, now can you ask your question again? Such that the members can get it well.
I'm asking that why do we have to say motion is the change of position of an object with respect to its surroundings? Because I thought the object just changes its position in a given time. I don't understand what they mean by with respect to its surrounding.
Oh, okay. Let's hear from 3 people before I come in. I'm going to start with the SM. SM, tell us what you think.
I think it's because if you're moving in air like on the road, the way a person moves differs from when you're moving like in water. When a person is swimming, the motion becomes different from when that person is just walking.
Okay, thank you. That is one. Let us hear from Van. Thank you.
Okay, like, so for me, what I get, like the reason also we say according to the change in the position of the object, like, guess, can you take a look at that tree? Like, if there is no wind or maybe a car passing at a high speed or something, it's gonna be like still, it won't be moving, like, okay, like there won't be motion. But if the car like now comes and passes at a very high speed, like those leaves will do what? Will, how can I even say, like they will move. So yeah, that's also like motion. It has moved an object.
Okay, thank you. Is it check, Devi? Thank you, Van.
Okay, so according to me, with respect to its surroundings, it means like for us to prove that an object is in motion, for us the surrounding, like maybe when something is moving, we have to feel and like to prove it and say it has moved in a given time interval. We shall have to see that from this time, okay, like maybe 5 seconds, it moved from this place to this place. And so it is us to prove. So that's what I think.
Okay, thank you. Then lastly, Harriet.
Teacher, me, I think it's about when they say with respect to its surroundings, it means this object is moving because of its surroundings. For example, the people, okay, the men that you can see or the women that you can see running, that are in motion. The emotion respect to its surroundings because maybe they're in a race and their surroundings are their fans. So their fans cheering them helps them move. For example, when you look at the car, the car is in motion. Actually, the car is in motion in respect to its surrounding, which is who is the driver. So I think that's how it comes about.
Okay. Now, when we refer to the surrounding, here we are looking at the environment where you move or where movement takes place always contributes to your movement. Whenever you are moving from one point to another, there are other factors that may contribute to your motion. So when someone is running, in space, there is what you call air resistance. You can have that air resist the motion of a person to move. So that's why always we say that always it must be with respect to a surrounding, because the surrounding contributes to the motion of an object from one point to another. So that surrounding, it determines. So that's what you call classical physics, that in classical physics, we look at those particular things like the air resistance and other factors that may resist the motion from one point to another. So surrounding is coming in this definition to let you know that when you are looking at motion, there are other factors that may hinder your movement from one point to another, much as you could be able to move far away, but because of some key things, you may not be in position to move. So surrounding is representing which other factors that can contribute to the movement. Yes, Valeria, you have a question?
So I've not got your point well. Can you repeat?
Okay, I'm saying that when we refer to surroundings, we are looking at other factors that can contribute or that can hinder motion to take place. So one of the key things, we can look at air resistance. Whenever someone is running, there are other forces that may act on that person. One of them that is very common is the air resistance that can pull you. So that one is what we consider in the surroundings. So we look at other things outside. Apart from you, what is that thing that is contributing to your motion? What thing might hinder you to move from one place to another? So that is what is contained within the surroundings. So the surroundings contribute a lot to your movement. Okay.
Okay, so.
Okay. Now we can continue. We are going to continue. So an example I can use furthermore is when you are in a pitch. Whenever you are in a pitch and you kick a ball, you may aim at shooting a ball, but many of the times you find someone kicking a ball straight to the goal, but you find that the ball has changed the direction. What changes the direction is the surrounding the ball is meeting on its way. So one of the things that changes the position for the ball is the air resistance, is the air that it is going to meet on its way. So you may kick a ball and you have aimed at it moving in a straight line, but towards the end, you see it curving away. So the surrounding has contributed to the motion of this ball. It has made this ball to bend and to go off your target. So we have here something. If you kick a ball, it can either go straight or it can curve. So this is someone who is kicking a ball. So when you look at this person kicking the ball, he has kicked the ball straight to the goal. And this ball has gone straight the way he wanted it. So that kind of motion is what we call linear motion. So whenever we are talking about linear motion, we are looking at objects moving in a straight line. And these objects are always covering an equal distance at equal time intervals. That's what you call linear motion. So linear motion, whenever you see the word linear or the word rectilinear, it means something that is moving in a straight line. When we talk about non-linear, it means that you are not uniform. And something that is not uniform, it means that this thing can either be a zigzag, its speed can change, it can be, it cannot be uniform. So when you look at that person, this person was kicking a ball, and this person kicked a ball, and the ball went in a curved way. So this kind of motion is what we call non-linear motion. So non-linear motion means that the objects do not move in a straight line. They take on any path that has been created depending on the surrounding environment. That's what you call non-linear motion. So I want you here to pick and create two definitions of your own of what we call linear motion and what we call non-linear motion. Feel free to share with us in the chat how you have defined what linear motion is and how you have defined what non-linear motion is. So I'm looking in the chat. Okay. Yes, I can read some of the definition. Linear motion is the movement of object in a straight line. Linear motion, movement of object in a straight line. Okay. Okay. Okay, good, good. Yeah. So create your own definitions. Create your own definition. Yes, yes. Now, further, here I'm going to bring in a point, what we call always the reference point. So when we are also looking at at a surrounding, also we look at what we call a reference point. When we refer to a reference point in a surrounding, is like a place or an object that is not moving. What you compare to say that you are not moving. Like when we looked at the car, we said our car is moving from point A to point B. So point A is the reference point, is what we are referring to, that is where our motion is starting from. So that point of reference in physics, we shall call it the reference point. Yes, Philip. Philip. Philip, unmute. Okay, I'm failing to get Philip. Okay. Okay, yeah. So I think that is okay. Can we continue? You can unmute and let us know whether we can continue. Yes, Michelle, ask.
I've not understood that part yet.
Which part? Michelle, unmute.
I've not understood that part yet.
Like which part?
The one that you're from explaining about the reference part.
About the reference point, eh?
Yeah.
Oh, okay. Now, okay, allow me to take you back to what we call the reference points. I'm going to use this. When you look at this vehicle, it is starting from here and it is going here. Now, this point A is like your point of reference, is what you are looking at to determine whether you have progressed on your movement. Otherwise, if you stay in this same place at point A, it means you have not moved. There is no motion that has taken place. So this point that you refer to be your starting point, we shall be calling it the reference point. What do you base on to know that you have moved or you have progressed from one point to another? In order for you to know that you have progressed in academics, it means that you have moved from one class to another. And you can compare yourself with someone who is still in senior 1. That for me, I'm in senior 2, and for him is in senior 1. So someone in senior 1 is your reference point, is what we are referring to show you that now you have progressed from one point to another. So still, when it comes to motion, it means that your position where you have been must always change. So that change in the position, where the one that you compare to show you that you have progressed, is what we shall be calling the reference point. So, and that point is like a static point. It's not like moving, but yes.
Okay, thank you.
So I think now we can continue. Okay. Okay, hope we are on the same page. Hope we understand. Okay. So hope everyone has defined what you call linear motion and what you call non-linear motion. But the keywords there, I expect you to say straight line, not straight line. At least those things must at least appear. Okay. So motion of an object, we mainly describe it mainly using 3 parameters. By show of hands, can we measure? Oh, no, let's use the chart. Use the chart. When you are describing a motion, what are those 3 words that we usually use? What do you base on to usually say that there is motion? Joyce Streamer is saying distance, speed, and time. Very good. Rama is saying distance, time, speed. Good. Distance, change in position. Remember, there must be 3 words: speed, time. Agatha, Teresa, Mega. Yes. Yes. Okay. Speed, velocity, acceleration. That is perfect. Martha, okay. Yeah. So those are those, yes. So those words you have mentioned are the words. So can we write them down? Let everyone now write those 3 common words. You can also look at the screen. I've displayed those words. Those are the main ones: the distance, the speed, and the time. Whenever you're describing the motion, those are the first ones that come in. Then, and others that can come in, we can have displacement, we can have velocity, we can have acceleration, and the rest. But the major ones is distance, speed, and time. Then the rest can come in later on. So write them down. Okay. Has everyone finished? Kindly unmute and tell us.
Yes, sir.
Yes, sir.
Yes, sir.
So you're finished.
We're finished.
Okay. Let me now mute you. Okay. We can now continue. And now we are going to look at the terms used. So the first term we are going to look at is what we call distance. Can we use the chart? everyone to type in what you think, what is distance? You can use the chat, what you think distance is. So our heading is terms used in linear motion, but we need to know what is distance. Feel free to type. Pauline is saying a length between 2 points. Prime is saying is the change of speed with time. Length moved by a body, that is Akram. Joyce is saying distance is the length of the space between 2 points. Length between 2 points. Distance is the path taken. Length from one place to another. Distance to the area covered, Mega. An area covered by a body. That is Rama, Van. Okay. 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 I think we have the answers. Okay. Audrey Mwine is saying length between the original point, the resting point. Very good. Length of the space between 2 points. Perfect. Perfect. Then I'm going to ask the second question. What are the SI units of distance? Which units do we measure distance in? The one is saying length between 2 points. Good. Meters, kilometers, meters, kilometers, meters. Okay. Okay. Okay, kilometers. So my question was, what are the SI units? So those people were mentioning kilometers. Kilometer is a minor unit, but the major unit is meters. And now our next debate is going to be the spelling for meters. I've seen 2 differing spellings of meters. Some are using M-E-T-E-R, others are using M-E-T-R-E. Now, which one is the best to use? I know all of them are correct, but which one would be the best?
Sir, it is M-E-T-R-E-S, the best, because we speak British English.
Okay, perfect, perfect. Yes. So those people who are using the other one of M-E-T-E-R, please check it out. Yes, check it out. That is Mega. Mega has told us meter is a device. Okay. Yes. So please check out your spellings whenever you are dealing with those units. Very good. Very good. I think I need to teach you another thing. Still about those units. Now, when it comes to units, when you use a capital letter, to write your units, take an example. I can give you an example of the common unit you have is Newton. Newton is one of the common units you have been writing. So when you write like this, this one is wrong in physics. So when someone writes like this one is very correct. So still when it comes to meters, when you are writing capital letters, you need to be very careful with them. We need to be very careful with them. For you'll notice that when it comes to names of people, names of scientists, we usually use a capital letter. So any unit you find that the letter is a capital, any unit where you find that the letter accompanying it is a capital, that one is an indicator that that is the name of a person. Anything you find. So that's why when it comes to Newton, so where you use those units whereby the letter is a capital, we always use capital letters. For names whereby it's not a name of a person, we use small letters. So for any unit where you use small letters to represent it, like meters, kilometers, these are not names of people. So you need to be careful. So when we are writing Newton, this is the best way to write it. Not to start with a capital N. Okay, hope that is understood. So whenever you find a capital letter in units, just know that was someone's name. And also you, whenever you discover something in physics, those units can be named after your name. So take an example, okay, let me, no, we have already, Kelvin was a name, so that one is already there. Let me say Felicitas. In case you discover something, they can use capital F to represent. So your name will be written in small letters as Felicitas. Okay. So, now that is it. So in the chat, can we also type the formula for finding distance? What is the formula for finding distance? How do we find distance? So let me see, use the chat. Yes, Newton was the name. Newton was the name of a scientist. Okay, speed times time, speed times time. Okay, 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 perfect, perfect, perfect. Okay, perfect. So we're right, okay. This is very good. Very, very good. Thank you, thank you, thank you, thank you. Good, good, good. Okay, now let us make some smaller notes about what distance is. So make some smaller notes on what distance is. So let us summarize our first term.
So we are done.
You are finished?
Yes.
Yes.
Okay. Okay. Let me test some people.
Yes.
Yes. Okay. Anyone who has
Yes, sir.
Angel, have you finished?
Yes.
Angel, have you finished? Daniel, have you finished? Adela, have you finished?
Inquiring about the reason why we call distance a scalar quantity, not a vector quantity. I'm confused.
Oh, okay. Allow me now to mute. Now, when we talk about why do we call distance a scalar quantity and not a vector quantity? So someone I think wants to answer. Let me start with check. Why do you think so?
Okay, so distance has only magnitude or size, whereas, okay, it has only magnitude, which we say it is a scalar quantity. But if it has both magnitude and direction, that is a vector quantity.
Okay, thank you so much. Yes, let me say, Patricia, you want to say something?
Okay, it's the same as James.
Okay, good. Now I'm going to talk about it. So when we talk about distance, like they have told us, distance, we are looking at size. We are looking at how far have you gone? We are not interested in which direction you have taken. We are not interested. We are not interested in how you have turned the corners and the rest of that. So distance, we are only interested in how far have you gone from your starting point. That have gone 50 kilometers, that is enough. You have gone 120 kilometers. I've gone 30 meters. That is distance. We are not interested in direction. And for any quantity, that is what we are calling the size of it. So size, it refers to, when we talk about size, we are looking at how big is the distance you have covered. How big is it? How long is the distance? How big is the distance that you have covered? So things like big, small, those are what we call the scalar quantities. But the moment you start looking at the direction that you have taken, that I turned left, I turned south, what, then you are bringing in the issue of direction. So for distance, we are only looking at how big have you covered, how far have you gone, that is the distance. So that's why you call it the scalar quantity. So we are looking at from your starting point to where you are, how far is that? Okay. I think now we can go to the next term and the next thing, activities. But let me go back. Let me hope everyone has been able to come up with this formula. So you remember, I think we did it some time back, but always remember this one that is shaded is the distance. So to obtain distance, multiply speed times time. But remember, I want to warn you very well that never assure. These ones are not the, let me say, are not the right, it's not a must that these are the letters you are supposed to use. So whenever you are dealing with physics, you can always use your words. Feel free always to use words because S can stand for something. S can stand for speed. S can stand for scalar. S can stand for Steven. S can stand for anything. So distance, speed, they don't have specific letters to represent them. So that's why always it's better to stick to your words, that is speed times the time. Okay. Hope that is very clear. So now we are going to try out a few numbers. Calculate, we are going to calculate all of them. And then after we shall share our answers. So try. It should take us 5 minutes. No. Let me, I think, mute everyone. So calculate and then share your answers. Okay. I think we have got the answers. Yes, I'm seeing very many answers coming in. Okay, 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 okay. Okay, okay, okay. Now, there is something you're going to learn. Okay, thank you, everyone. I'm seeing the answers are okay. Now, always, whenever you are making calculations, make sure that whenever you find units in meters per second, these units always go with seconds. In case you find that your speed is in meters per second, then your time must be in seconds. In case you find that your units are in kilometers per hour, and this is your speed, then your time must be in hours. So whenever you find that this hour, the time is different, let me say it is kilometers per hour, and the time is in seconds, then make sure that you convert the seconds to hours to match. Kilometers per hour, go with hours. Meters per second, go with seconds. So in case you find that the units have been interchanged, that one is in seconds, another one is in kilometers, that's when you have to go on and change them. But should they be matching in that format, feel always free to work it the way it is, unless when they have asked you to convert them to specific units. Okay, can I have someone to take us through number 1? Any volunteer? But I'm going to be selective this time round. At least I've not heard from Agatha. Yes, Agatha. Agatha?
Okay. Question number 1 says a marathon runner runs at a speed of 5 meters per second for 3 seconds. What distance does he cover? And as you've been learning about distance, we say to find distance, we multiply speed times time. And since both are given, we just go straight and say distance is equal to speed times time. So we shall multiply 5 meters per second times 3 seconds. So both the seconds will be moved since the value is common. And then we shall remain with an answer, which is 15 meters.
Thank you. Thank you. And please take note that this meter is a small letter. So I expect you to write a small letter M, not capital M. Okay, thank you, Agatha. Can we have someone to take us through number 2? I'm checking someone who has not yet contributed. Shannon. Then Wandela, you'll come in. Shannon.
Number 2, Philip is driving a car at a constant speed of 60 kilometers per hour for 2 hours. So the distance will be distance equals speed times time. And in this situation, our speed is 60 kilometers per hour. So it will be 60 kilometers per hour times 2 hours. The hours will cancel themselves out. Then it will remain 60 kilometers times 2, giving us 120 kilometers.
Thank you. Thank you, Shannon. Okay, then the last one, we had a boy. Where is Akram? I saw Akram's hand up. Any boy to take us through number 3? Yes, Akram.
Okay, number 3 says a train is traveling at a speed of 160 kilometers per hour. It takes 15 hours to cover the distance from city A to city B. Find the distance between the two cities. As our formula is distance equals to speed times time. And we have 160 kilometers per hour as the speed, and then 15 hours as the time. So the hours and hours will cancel out, and we remain with 160 kilometers times 15, which gives us 2,400 kilometers as our answer. Thank you.
Thank you, Akram. So please check out that is what you have. So the kilometers per hour people were telling us, because remember kilometer per hour and you're multiplying it per hour. So when we say kilometer per hour, it means kilometer out of hour. Then times this hour. So these ones end up cancelling out. So that is the meaning. So you remain with kilometers. So your answer can be in meters, it can be in kilometers. Even in some questions, you may find them in feet. That one is also possible. Yes, Ethel?
Yeah, I was just asking that, and we supposed like to change these kilometers to meters are SI units.
Okay, yes. Now, Ethel, that one can be okay if the question has asked. But if you find a question when it is in some normal units, feel free always to work with those units. So change when the question is not in the normal units. Take an example. In case you find that our speed has been given as 60 kilometers per hour, but when you look at time, time is given in as maybe 2 seconds. Here, you are required to change. And here, the best units to change to are the standard units. But if you find that the kilometers per hour is matching with the hours they have given, kilometer per hour goes with hours, work out in those units. If you find meters per second and seconds, work out in those units. But should you find meters per second and hours, here change. The time must match. Hours, hours. Seconds, seconds. So that's when you change. Okay. Hope that is very, very, very okay. Okay, thank you, thank you. Yes, those who change, you'll find that you are getting, but in case you know how to change, feel free always to change. You'll get the same, the answer will be almost, it will be the same answer, but with different units. That's the only difference. Yes, Adela? Adela?
Thank you, but I'm inquiring, are we supposed to change to the SI unit like on number 2 and number 3? Is it supposed to, are the answers supposed to remain in hours, or we must change them to seconds?
No, that one is up. Now, like I've said, Adela, don't mute. Like I've said, for these ones, it is up to you. In case you decide to change the hours to seconds, then change the kilometers per hour to meters per second. If you decide to change them, take them to the same units. But should you find that this is kilometer per hour and these are hours, this is speed and this is time, should you find that these hours are matching with what the units they gave you, there is no need for you to change. Work out the way it is. Unless when the question has said, giving your answer in a given unit, maybe in meters, there it is okay. But if you find that these ones are matching, no need for you to waste time to change. You find meters per second and second matching, there's no need for you to change. Unless when the question maybe has told you, find a distance in meters. That's when you can go on and change. And now whenever even you are dealing with these distances, when the units are matching and they want you to get the answer in a given unit, you can as well even do it towards the end after getting your answer. Is that fine?
Yes, it is.
Yeah?
Yes, thank you. Okay.
Okay. I think we can now continue and look at another factor. Another factor, another term we are looking at is going to be, let me see whether people have ever seen this. Type in the chat what that picture. What is the name of that picture? Let me see whether people have seen it somewhere. Just type in the chat the name of that picture. It's called speed time. speeds, odometer, ammeter, I think. Speed, good. I think speed, So I've got two people. One of them is Ban, and another one was Mega, who gave us the correct name. Yes, and Van now. Okay, now people are starting to give the answer. So those who have cars at home, I think this thing is very common. When you look at the dashboard in front where the driver sits, we usually find this. So when you look at this always, there are three of them. It depends on the nature of the car. You can find this one. It shows you the fuel. So this side here is the one for that indicates for you the fuel. Then this side, when you look at degrees Celsius, something has to come into your mind. Degrees Celsius, what do you think this, the right, according to me, to be the left, what do you think it will be measuring? Yes, good. Okay, yes, Patricia?
Temperature.
It will be measuring the temperature. Very good. Then when you look at the middle, in the middle, you always look, they always put the units. So those units must be able to guide you. So what do you think this one in the middle is representing? You can use the chart and type and we see. Okay. The one in the middle, speed. Very good. So the one in the middle, kilometer per hour, should be able to guide you that it means it is for speed. So this is the one that we are going to look at. And like people have mentioned, it is the one that is used to measure the speed at which the car is moving on. So we call it a speedometer. Yes, Van, you want to say something? Okay. Okay. So our next item we are going to look at is called a speed. So I want you to use the chart to tell us, what do you understand by speed? When someone say, that person drives very fast, what do you think speed is? We can use the chart to type in what we think speed is. Oh, it's also called odometer. Okay. Speed is the rate of change of distance, how fast or slow an object moves. That is good. The ability of an object to move at a fast rate. Speed is the distance and the time an object takes to reach a place. Okay. Rate of change of distance, rate at which a body moves, ratio of distance over time. Okay. 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 That is perfect. That is perfect. In the chat now, can we type in what are the units for speed? What are the major units of speed? What are the major units of speed? Okay, meters per second, meters per second. That is very good. That is very good. Then now, in the chat, let's write also the formula. What do you think the formula for speed is? How do we calculate speed? Okay, very good. And now let us make smaller notes. Thank you, everyone. Thank you. Thank you. So let us make some smaller notes on speed. Ian Kayongo, unmute. Okay. So let's make some smaller notes.
Guys, what's happening?
We are making some smaller notes on what speed is. Yes, Akram.
Yes, sir. I'm not well versed with the SI unit of speed because I see most of them, like many are on meters per seconds, and the number of them is on kilometers per hour. So I'm not settled with this unit.
Okay. Now, Akram, like it comes from here. We know very well that speed, we know very well that speed
network.
Sorry, allow me to share again. Hope my screen is on. Hannah, is the screen on?
Yes, it's back.
Okay. So we know that speed is given by distance out of the time. So what are the SI units for distance?
Meters.
Meters. What are the SI units for time?
Seconds.
Seconds. So speed is given by meters per second. Or in some books, you'll find them writing meters per second.
Okay.
Yes. So these are the SI units. So the SI units are meters per second.
Okay, thank you, sir.
So the minor units are kilometers per hour because distance can also be given in kilometers out of hours. So it can as well be kilometers per hour. But these are minor units. But the major units are meters per second. Okay, thank you, sir. Okay. Has everyone finished? Are we good to continue?
Yes.
Members, you can let us know.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Okay. 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 Melinda, you have a question? Melinda?
Yeah.
Okay.
I have a question.
Yes.
Now is velocity and acceleration the same as speed, or because also those ones have also the SI unit of meter per second?
Okay, now velocity is related to speed. Velocity is related to speed, but that one we are going to look at it. Acceleration is also related to velocity.
Yes.
So those are, we shall look at acceleration, the units are meters per second squared, not meters per second.
Okay.
So we are
Thank
going
you,
to look
sir.
at that. We shall look at them.
Okay, thank you, sir.
Okay. Okay. So we can now proceed. Hoping everyone is here. So these triangles we are having on the screen are very good. So your calculation, sorry. Find the answer. Calculate for me that one quickly, everyone. Let me check. Okay. Nina, 50 kilometers. Change. Charity, Nina, Heather, Audrey, Melody, check out on your units. Melody, check out on your units. Nakanyike, Judith, Jemima, Primes, Anita, Redeemer, check out on your units also. Akram, Faith, you are missing units. Tess, you are missing units. Patricia, that is okay. Valeria, okay. Veronica, okay. Mega, okay. Stacy, okay. Tess, okay. Michelle, okay. Viola, okay. Emily, okay. Sylvia, okay. Jolene, okay. Shannon, Daniela, Ricky, okay. Joyce, okay. Van, okay. Cherop, okay. Van, okay. Yeah, I'm saying correct answers. Correct answers. Ariana, okay. Otim, okay. Angel, are you progressing?
Yes, teacher.
Okay, Angel, can you take us through?
Okay. We first write the formula. Speed is equal to distance divided by time.
Okay, good.
So 150 kilometers divided by 3 hours. And the answer is 50 kilometers per hour.
Okay, thank you. Thank you. So that is very okay. Hope everyone is okay with that. I think we can move on. Okay, so we are going to the next one is time. Now, when we come to the time, I have put the different things we can use to measure time, and I'm going to ask you to just make a simple summary when it comes to time, and also we are going to try out this number. So make a summary of time, and what is very important is you knowing how to find time using the formula. Those who are not familiar with this formula is that when you are looking at time, you get this distance out of the speed. So right about time, write the formula, and we are going to try out that question. Okay, am I saying answers? So I'm checking. Okay. That is very good. Very, very okay. Okay, okay, good. Okay. Okay. 17, 17. Okay. Okay, 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 okay. Okay, good. Okay. Let me ask any. Daniela? I've seen Daniela. Daniela, do you wish to take us through? Okay, anyone who wants to take us? Okay. Akram has contributed a bit. I want someone who has not yet contributed. Patricia has contributed. Joylin Adela has contributed. I want someone who has not. Van has contributed. Joylin. I think Joylin has also. I think Joy, this one has not. Okay. Joy.
Yes. The question says, how long does it take for a car to travel 68 meters at a speed of 4 meters per second? So time equals to distance divided by speed, which is equal to 68 meters divided by 4 meters by 4. Yes. Then when you divide, you get 70.
Okay, thank you. So,
you're welcome.
Yes. And now one thing you're going to notice is that here, the units they were using words. So always feel free, you can use the abbreviation, but the best would be also using the words 17 seconds. Okay. Patricia, do you have a question? And Becky?
Yes, sir.
Okay.
Is there a specific, like, does time have a SI unit?
Yeah, the SI unit is seconds.
Okay, thank you.
Okay, you're welcome. So in the physics lab, this is the instrument we use to measure time. Whenever you are in the physics lab, we use this timer to measure. We call it a stop clock. This is what we use to measure time, and it measures in seconds. Also, this one is a watch we use when it comes to physics. Those people who have been into sports, we also use it, more so when it comes to these things of running. They use it because it times the minutes. So this one, these are minutes. It can go to seconds. It can go to microseconds. So it is mainly used when it comes to running. Okay, there's a question from Akram and then Joel.
Sir, you have already replied my question. Someone answered it, asked it, and you answered.
Okay. Yes, Joy?
Yeah, like, excuse me, sir, which kind of quantity is time?
Time. Okay, time is the scalar quantity.
Okay, thanks.
Yeah, because for time, you don't need to tell the direction. Yes, for time, there is no need for you to tell the direction that maybe it was moving this side. No, for it, it is a scalar quantity. Also, speed is a scalar quantity. Yes, Melinda.
Sir, you say that the SI units of time in seconds, not so?
Yes.
Now, what if they give you like this, like the distance in kilometers and the speed in kilometers per hour? Now, when you get the answer in hours, is it okay? Like, is it a must? You must convert it to seconds.
No, it's not a must.
Okay.
Unless when the question has said convert to seconds.
Okay.
Okay. Okay. Melinda, you are the last. Okay. Okay. We can now proceed to the next part. So we are almost coming to the end. So we are going to look at the next thing. So the next one is this, and this is the main concept I want us to understand today. Yeah, I know you have understood the other ones, but this one is also very crucial. I want us to use the chart to tell me the total distance. I think there's a bicycle here. This is the bicycle. This bicycle is moving from point A, coming to B, coming to C, and coming to A. Tell me the total distance covered in the chart. What is the total distance covered? Very good. Very good. Perfect. That is very good. Now, we are coming. I'm going to go to the next picture. Observe very well. The next picture, we are here. We are coming. I have this person. This person is maybe, this is a boy. I can use Philip. Philip is moving from A, coming to B, coming to C, coming to D, and coming back to A. Tell me, what is the total distance Philip has covered? Hope you have understood the journey. From A, it goes to B, from B it goes to C, from C is coming to D, and from D is going to A. What is the total distance Philip has covered? I want to see. 16, 12, 16, 16, 16, 16, 15. Here we are getting answers a bit different. 16, some are saying 16, I've seen 15, but 16 is the common. 16 is common. Yes, 16 is common. Can we have someone to tell us how we are getting 16? Sylvia?
because here on the length they are equal, with this they are equal. When we have 3 this side where the boy is standing on the width, it's the same this side we are having 3 meters.
Okay. Okay, so when we add the total, we are getting 16. Okay. Okay, very good. So when you add 3 plus 5 plus 3 plus 5, you end up with 16. Now, my next question, what is the displacement? Type in the chat. What is the displacement? Let me check people's answers. What is the displacement? What is the displacement? So, I'm going to check 1, 3, there's no displacement, 0, 0, 80, 0, 8, 3, 15, 16, 5, okay, 15, good, good. I have Prime, do you have something to say?
Yes. Yes,
okay.
My answer is 0 displacement, because displacement is a vector quantity which has magnitude and direction. And this boy is moving from A to B, C to D, then back to A. So he has moved 17 meters as his distance, and displacement is 0. Turn back to the same point, which is A.
Okay, thank you. Thank you so much. Okay, yes.
Welcome.
Okay, now people ask, what is displacement? Now, when it comes to displacement, we are looking at 2 things. We are looking at the distance and we are looking at the direction. When we look at displacement, here we are looking at the straight line that straight line that joins the starting point to the ending point. So you look at the line, when you draw a straight line from starting point to the end point, what distance is there? That's what we call now the displacement. So A being the starting point and being the end point, when you draw the line, it shows you that actually this person has not covered anything because he has remained in the same position. Hope we are together on that. Let me first ask. Let me allow to unmute. Is that point okay?
No.
Yes.
No.
Okay. Okay. Now, when we are looking at displacement, okay. Okay, now let me explain again. So when we are looking at displacement, let me mute you. When we are looking at displacement, I'm looking at from the starting point to the end point. So you draw a line from the starting point to the end point. So this is the starting point and this is the end point, meaning he has come back to the same place. Alternatively, I'm going to use direction. From today onwards, whenever you are dealing with direction, whenever someone is moving in the north direction, mathematically or physically, we call it a positive direction. Whenever someone is moving to the right-hand side, that is positive. Whenever someone is moving in the west, that is negative. Whenever someone is moving down, is negative. So that's why when you look at your number lines, when you look at the graphs, always up here we put positive numbers. When we are going this side, we put negative numbers. When you are going this side, we always put positive. When we are coming down, we put negative. Now I'm going to look at the arrow. When the arrow faces, let me first mute you. When we look at the arrow is moving upwards, meaning it is moving in a positive direction. So I'm going to start calculating that displacement. Since the arrow is moving up, I'm going to say the distance is 3 from A to B. So this person started from A to B, then from B, he went to C, then from C, he went to D, and then from D, he came back to A. So when you look at A to B, this person is going up. So up is positive. So I write it as positive 3. Plus, when I come from B to C, this person is going to the right. And we said anything to the right is positive. So I write positive 5. When I come from C to D, this person is going down. So we said anything coming down is negative. So I write, we know here there is 3. It will be plus negative 3. From D to A, this person is going to the left. And we said anyone moving to the left is moving in the negative direction. So I say plus negative 5. So when we do our mathematics, plus 3 plus 5 is 8. Then plus negative 3 plus negative 5 is negative 8. So 8 plus negative 8, this is the same as a minus. So it becomes 8 minus 8, which gives us a 0. Reply in the chat whether that concept is fine. I want to check in the chat. Has everyone understood that? Okay, 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 okay. It is okay. Fine, fine. Now take an example. I'm asking, I want to check whether people now have understood. What is the displacement? What is the displacement of this person, this boy here, when he moves from A to C? What could be the displacement? Hope we have got it correct. God knows. Let me check. Yes, God knows. God knows? God knows.
It is 8.
It is? Okay, good. Okay, Van? I'm not getting Van.
Sir, it is 8.
8, Let me check. Prime?
So it is 8 because 3 meters upwards is positive. Then from B to C is positive 5. So 3 plus 5 is 8. So the 8 meters.
Okay, Check.
It's the same, 8.
Okay. Yes. So now, alternatively, when you measure from, so that is how, okay, we can leave that one. That is what we call displacement. We call it displacement. So displacement, you look at the direction someone takes. And that's where our exercise is going to be, understanding that word displacement, because it's going to be very crucial whenever we are dealing with these things. So can we make a summary? So whenever you are looking at displacement, you are looking at the distance moved and the direction. And always in simple terms, displacement is that shortest distance from the starting point to the end point. Yes, Prime. Okay. So let us summarize. Summarize. We are running out of time. Summarize. Have we finished to summarize? Check, what are you saying?
Okay, sir, I'm asking, like, if they tell us, like, what is the displacement, how do we state the answer since it's a vector quantity?
Oh, okay. We are going to look at that. But when you are stating, let me use this gentleman here. When I'm using this gentleman here who is moving, I'll measure the distance from the starting point to the end point, from here up to the end point. Let me say there are 5 kilometers. So I will say the displacement is 5 kilometers. So this is the distance. Then I look at the direction. Which direction is this gentleman taking? So let me say, you tell us, in fact, check which direction is this?
East.
East. So I will say the displacement is 5 kilometers towards the east. So that's how you state it. So you have given the distance. This is what we are calling the magnitude, or what you are calling the size. And this is what you are calling the direction. So you have stated the displacement. So since you have mentioned magnitude and direction, that's why you are calling it a vector quantity. And always when it comes to a vector quantity, displacement is related to distance.
Okay. Thank you.
Okay. Yes, Akram?
Yes, sir. Is it a must that you have to put the direction? Because I see the answer is 5 kilometers towards the east. Is it a must? Because if I just write 5 kilometers, they be right.
Okay, now it will always depend on the question. There are questions that are open, that don't have any direction. So for those ones, write what you have got. Yes, but in case the question involves the direction, then mention it in case you can be able to locate the direction. But when you advance, at times we use angles. So at times you may find using an angle, but that one will come in at another level where you use an angle to locate, like in bearings. So when you are in bearings, that direction you give is the displacement.
Okay.
Quags. Is it Heather? Unmute. Quags, your network is really betraying you. Oh, we are going to share it. We shall share it. No worries. Okay.
Thank you.
Okay. Then I think everyone has finished that. So this is your homework that you are going to read about. So just write it down somewhere, what you are going to read about. When we come next time, these are the things we shall be looking at. Read and you can make some notes. What is average speed? What is velocity, acceleration, motion, and graphs? In fact, I'm seeing the WhatsApp group is already in the group. Okay, hope people have taken notes. So we are going to end at this point. We shall end at this point, and we shall, let's meet next week. So tomorrow we shall continue to have lessons. Those who still want to learn, I can post some link for you to try out some little exercise. I don't know how many of you are still strong. Let me check. How many of you are still very strong? I wanted to give you some. Yes.
I am.
Okay. Let me give you some. It is just a small quiz. Okay. Those who have used quizzes, they're just 12 questions. They're just 12 questions that we are going to try. So those who have done this, just go to join my quiz and we try it for a few minutes. So I'm going to type in the chat. Yes, but those who are really tired, feel free to rest. But this quiz is about today's lesson. So they're just 12 numbers. So I've posted the link. Click on that link. Click on that link. Click. And then when they ask you for the code, type in that code. Type in that code. This is the link. This is the code. Okay, good. I'm seeing people are entering. Yeah.
I'm saying read the code.
The link is in the chat. Just say join my quiz and then you place in that code. So far 13 people have joined. Can we start?
Not yet.
Okay.
Shit.
Okay. Can we start?
Yes, sir.
Yeah?
Yes.
We start. Okay. Let's start.
Good. That's incorrect. Speed. Lion heart.
I think I want to check who has been the best. Okay, I think it was good. It was good. Is there any number that was so hard?
The last one, sir.
The last one. Okay. 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 I think some missed out because they joined a bit late. Yeah, but that is good. So I think we shall start from here next time we meet. The last one was about, let me just check. So we shall start from there when we meet. Let me wish you a good afternoon. Bye-bye.
Bye.
Bye.
Bye-bye.
Okay, bye.
Bye.
Okay, bye.
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 Bye.